So, dear students, yesterday we have finished the aldopentoses. Now, today we are going to study aldohexoses. Now, here we have aldohexoses. So, aldohexoses, we have many aldohexoses. And the first aldohexose that I'm drawing is CH2OH. CHOH. This is so here we have, this is the D-allose. This is D-allose, and then we have next one, which is I'm drawing this time D-Altrus. This is OH here, H here, and so it differs here. You can understand this is I'm drawing another structure, another color here. This is H and OH. So this is different from here. And let's have a look at this is different here. This is D-Altrus. D-allose and D-altrose. So these two are here different. I'll show you where they are different. And these are different here. This is different here. This is called D-allose and D-altrose. This is then next one. That is one, two, three, 4, 5, and 6. This is again CH2OH. This is OH. H. This is OH. H. This is OH. H. This is OH. And H, and this is C double bond O H. So let me just make it clear. Here we just add the color. That is so here this is the D-glucose. This is D-glucose, and this is then next one is, I'm just drawing here again. This is next one. And this carbon I will just use here. So here the two are different. This one and this one is different here. This is D-glucose and this is D-mannose. So D-mannose. Then we have 1, 2, 3, 4, 5, and 6. This double bond OH. And we have this one is the D-mannose, and then we have the gulose. This is here OH and H. This is OH here and H here. This is D-gulose. This is called the D-gulose. D-gulose. And here we have so again this is the D-gulose, and then we are drawing another structure which is D-idose. 4, 5, and 6 numbering. CH2OH, this is this. This is aldehyde carbon. And this aldehyde carbon, this is idose. Here we have OH, H, H, and OH. And then we have OH and H. And this is CHOH. So this will be called as D-idose. And this is D. And here I'm just using another structure, D-idose. This is D-idose, and here I'm just using another color. This and this are different here. This is D-idose. Then we have next one. 1, 2, 3, 4, 5, 6. And this is D-galactose. And this is H. This is OH here. This is H here. This is OH here. And this is OH and H here. This is D-galactose. And the last structure is 1, 2, 3, 4, 5, and 6. CH2OH, C double bond OH. This is CH OH. This again CHOH. This again CHOH. And here it is COH and H. So this is clear. Now just I would use another color here. This is HOH, and here again this is so this is the D-talose. Structure is D-talose. So these are all our hexoses. So these are the structures called as Fisher projection formula of aldohexoses. And here, the two here, each hexose is having 1, 2, 3, and 4 chiral carbons. So 2 to the power of 4, it will be 2 2s are 4 2s are 8 2s are 16 stereoisomers, 8 are D forms, and 8 are L forms. So accordingly, this is the work of the Fisher projection formula of aldohexoses. And if you take the structure of now, if we take the structure of glucose and glucose, again, I will draw the structure of the glucose. 1, 2, 3, 4, and 5, and 6. And this is glucose. Here, this is having OH, H, OH, H. And here we have again HOH. And this is having the OH and H. And this is C double bond O H. So we have this structure is called as D glucose. The numbering is here. I'm just going for numbering 1, 2, 3 carbon, 4 carbon, 5 carbon, 6 carbon. And here this is asymmetric carbon, asymmetric carbon, asymmetric carbon, another asymmetric carbon, and this is the D. And if I draw another structure now, C double bond O H, C O H H, and C H O H, and here I'll draw it like this, A and OH. Here I'll use like this. This is asymmetric carbon with OH here and H here. This is OH here. Using the black color so that you'll come to know about this is OH and H. 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, and 6 carbon. This structure is known as D-galactose. And if we see the difference between D-galactose and D-glucose, so these two structures are quite different here. Let's see, these two structures are different here. And let me draw it here. H and H. So rest of the structures are 2 is same, 2 is same. This is 3 is same, 3 is same, but they differ only at the carbon number 4, sorry, carbon number 4 is here. So carbon number 4 is here. This is D-glucose, and this is carbon number 5. This is the D-galactose. They are same here, but only the difference here at the carbon number 4 is here. This is the difference between this structure and this structure. At the carbon number 4, you'll see that. I'll just draw it to the. It's here OH and H. So that means glucose and galactose, they are different at glucose, D-glucose, and D-galactose are different only at carbon number 4, and hence these are called epimers. So these are called epimers. So kindly note the glucose and galactose are epimers. Glucose and galactose are epimers, and with this, we find that glucose and galactose are the epimers. Similarly, those structures which differ only around only one carbon, they are called as epimers. So glucose and galactose are epimers. So with this, we've finished today the Fisher projection formulae of the aldo hexoses, and next we'll just come to know about again epimers, and at the same time in next lecture we'll discuss the cyclic structures of the monosaccharides. This is all about it.